Okay, so I do want to do some quick calculations, some examples, I guess, of molarity and molality. Let me again, let's see here, grab a color that we can see on this background. But molarity, again, is M, capital M, moles per liter. Moles of solute per liter of solution. Molality is moles per kilogram. Moles of solute per kilogram of solvent. Okay, so those are your two formulas. Obviously I'll do one way of solving, let's say for the molarity, given these two things, and then I'll also give you two of them and solve for the moles. So again, just really rewriting algebraically. Know that you can obviously convert and molarity, molality, either of those can be easily used to solve for these types of problems. Okay, so let's see what we have. Our first one is, it says, what is the molarity? So again here, let me just interrupt everybody. I would hope that when you're solving these problems, you take what's given and then write what's given before you even go too far. So what is the molarity of a salt solution if 25.8 grams of salt are dissolved in 2 liters of water? Okay, so this is our solution. Obviously the 25.8 grams, that's our solute. Okay, so my formula, moles per liter, and so obviously the announcements are happening right now, but so I'm going to change my grams to moles because my moles of solute needs to be, for my formula it needs to be moles. So my moles of solute is going to be 1 over that 58.5, doing my dividing, 0.44 moles. And so to solve for molarity, I'm going to take that 0.44 moles divided by my liters, of course, 2 liters, 2.0 liters, let's say. Do that dividing and I get 0.22 molar NaCl solution. All right, there's my molarity example. I could also solve for grams of solution, and this is going to be a molal one. Let me grab a couple of different colors here. Again, let's let's get away from this. Let's do some green. Okay, so how many grams of potassium iodide must be dissolved in 500 grams of water to produce a 0.060 molal Ki? Okay, so again, notice I'm using molality formula this time. Moles of solute per kilogram of solvent. Again, moles of solutes on the top for both of these. All right, now notice I'm asking for how many grams. I'm giving you the solvent. Notice, see how it says in. So this right here is my solvent, and this is my molality. So I'm giving you these two. What's not known, let me grab a different color this time here. Whoops. Let's do yellow. All right. What's not known this time is my amount of solute. I'm looking for my moles of solute. In essence, I can then convert to grams. So I'm a big fan of rewriting the equation, solving for moles. So moles is equal to molality times the kilograms. I'm going to take my molality, which is 0.060 molal, multiply by my kilograms. Of course, this is given in grams, so it's a 3-place decimal move. Remember, there's 1,000 grams in 1 kilogram. 0.0 0.500 kilograms. I multiply those two numbers, whatever that is. Well, it's going to be 0.030 moles. I'm running out of room. I know my picture's right there, so let's just take this back over here. 0.030 moles. And now I want to, let me grab a different color here just for effect. How about, what color is going to work well on this background? Let's go this kind of this bluish one. Okay. X line, moles, grams, 1, whatever Ki is. And I think I have it written down over here. 166. Adding up potassium and iodine. And when I multiply those, I get 4.98 grams of Ki. And that's how many grams of Ki would be dissolved in 500 grams of water to give me a 0.060 molal solution. So there's again another example of how to use concentration to determine either how much you need to put in to get you your specific concentration, or what your concentration is when you put a certain amount of solute in your solvent.